This video was sponsored by Brilliant. It's been almost 2 years since I created the channel, and today I'm going to answer some of your questions. Hi friends, my name is George, and this is CodeCrafters. A lot of people have asked whether I'm going to make videos on certain topics, so here's a list of the ones I have planned for the upcoming months. If there's a specific topic not on this list that you'd like to see, feel free to let me know in the comments. Also, if this video receives a lot of likes, I'll post one more video before the end of the year. Believe it or not, the most frequently asked question is still how I make my animations. The answer: I use PowerPoint. I wasn't really planning to answer the same questions as last year. The only reason I'm including this one is that I've answered it more times than I can count, and people keep asking anyway. The funny thing is that when new viewers ask the question, and longtime viewers answer it for me, the new viewers are usually skeptical. But yeah, every video on this channel is made entirely with PowerPoint slides, as you can see here. Not a single frame of my videos is AI generated. Every concept I cover is based on knowledge I've gathered over the years. The only stage of my workflow where AI is involved is the voiceover. For that, I use 11 Labs, and then I sync the audio with the animations in DaVinci Resolve. That's it. That's my entire workflow. Another thing you keep asking about is why I use an AI voice, and whether I plan to start using my real voice someday. The answer is no. I'm not planning to drop the AI voice and start recording myself. At this point, the voice I use, this one, has become part of the channel's identity. If I suddenly changed it, I think more people would be upset than happy about it. My favorite programming language. I always answer this the same way. If I were stranded on a desert island in the middle of nowhere and could only take one programming language with me, it would probably be C. And if you're wondering why, it's because with C you can build almost anything. Other programming languages, compiler infrastructure, kernels and operating systems, databases, networking tools, and virtually anything. I think the real question is, what can you not build with C? By the way, I don't like C++. A lot of you seem to think that I know many things, and that I'm good at teaching them, because I come from a big company. The reality is that, unlike many YouTube dev channels, I've never worked at Google, Netflix, Twitch, or any of those companies. I'm from South America, where FAANG companies simply aren't around offering jobs. I understand why that might be disappointing, but I actually think it's a good thing. Because you know what that makes me? A regular person, just like most of you. And if I could learn all the things I teach on this channel, then you can too. Many of you are also curious about how I learned things that usually aren't taught, even in college. One thing you need to understand is that, as human beings, no two people learn in exactly the same way. There's no secret formula. Learning is subjective in many situations. But if you're asking this question, I'll assume you're naturally curious, and that's already a great start. The first thing I'll say is that you definitely don't need college to learn computer science. As someone with a computer science engineering degree, I can tell you that over 60% of what I know wasn't taught to me in college, at least not directly. I learned it because my curiosity pushed me to understand how things actually work. And I'm not saying you need to read a new book every week. In practice, most learning happens in small moments, while you're already doing something else, following a tutorial, fixing a bug, or trying to understand why some code behaves the way it does. For example, when you learn about POSIX threads in C, you usually follow a tutorial like this that tells you to create a function describing what your thread will do, create a structure, and then call pthread create, passing that structure as the first argument and your function as the third. The tutorial then tells you to fill the remaining arguments with null because you don't need them. After running the code, a bad engineer moves on, satisfied that the tutorial works. A good engineer, however, starts to feel uneasy, because what are those extra arguments the tutorial told you to ignore? Someone who really wants to learn will spend 5 extra minutes researching why would a thread might need attributes, what those default attributes are, and when would a thread receive an argument. One of the best comments I've ever read on this channel came from someone who did exactly that, ask himself questions. A few months ago, I made a video explaining that race conditions can't be fully solved in software because CPUs may reorder instructions through a process called out-of-order execution. Instead of closing the video and moving on, this person pulled out an old Mac and tested whether what I said was actually true. He even tried modifying the solution himself to see if it would work, and only then did he draw his own conclusions. If you ask me, that is what a good computer science engineer looks like. As I replied to that comment, this is the kind of habit I encourage developers to normalize. Tweak the solution and observe what happens as you make changes. Will the tweaked solution turn into a meaningful piece of software? Probably not. But you'll have learned something, and you'll be a better engineer than you were before. That's how you build knowledge. You don't find one perfect book with all the answers you want. You earn understanding over time. Speaking of books, some of you have asked which ones I recommend for learning low-level concepts. The first one I'll recommend today is this one, by Dennis Ritchie and Brian Kernighan. Whether you like it or not, we still live in a world powered by C, and that's not going to change anytime soon. I believe that learning C is something every developer should do at some point, because it forces you to think about code in terms of how computers actually work. This book isn't very long, but if you're someone who prefers learning a programming language by building things and picking up concepts along the way, I also recommend adding this other book, which focuses on systems programming. This one is especially important to me, because it's where my journey into the low-level world really began. If your goal is to learn specifically about operating systems, this next book does a great job explaining many of the concepts I talk about on this channel. And speaking of things that are good at teaching, have you tried Brilliant yet? If you're the kind of person who enjoys peeling back the layers of how computers actually work, Brilliant is hands down one of the best ways to push your learning deeper. Brilliant is built around a simple idea. You learn best by solving problems, not by watching someone else solve them. And when you experience that kind of active problem solving, you start to feel something shift. Concepts that used to feel abstract suddenly become intuitive. You start thinking more clearly, more logically, more like an engineer. Courses like Thinking in Code can help you build the foundations of knowledge you need to start building confidently. What I love about Brilliant is how it meets you exactly where you are. It figures out your level, adapts your practice, and helps you progress at your own ideal pace. To learn for free on Brilliant for a full 30 days, go to brilliant.org/coredumped, scan the QR code on screen, or click the link in the description. Brilliant's also given our viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. Another question I get a lot by email is why I don't respond to most sponsorship offers. I'll be honest, if I had accepted every sponsorship offer I received this year, I'd be very close to retiring already. I even received, not one, but 2, offers to buy the channel. You'd be happy to hear that's not happening. One thing you should understand is that I don't make these videos in a single day. They take time, and realistically, the most I can produce is about 2 videos per month. Because of that, I try to work only with sponsors whose products align with the core topic of the channel. Since this is mostly a developer audience, I focus on sponsors that genuinely provide value to developers. There have been a few exceptions, but I've done my best not to drift too far from what this channel is about. And by the way, if you contact me with a sponsorship opportunity for a product described as Build X with AI, you can be 100% sure I won't even finish reading the email. It's that simple. AI can provide a lot of value, but solving your life with a single prompt, isn't it? If you've wondered about my thoughts on AI, I do recognize that AI has real potential, and in its current state, it's already useful in many situations. I recognize that, when it's up to coding, AI is genuinely helpful for providing suggestions based on context. I really appreciate not having to type as much boilerplate code as I did a few years ago. What I don't agree with is the idea many platforms are trying to sell, that you can generate an entire application with a single prompt. And don't get me wrong, I have no doubt that AI will eventually reach that level, but we're not even close yet. For education, though, things are a bit different. Because of the hallucination problem, I would never fully trust an LLM's explanation of a concept. Asking an AI to teach you something is risky, because behind a well-written explanation, there might be a lot of confidently presented nonsense, generated simply to sound helpful. That's literally what these models are optimized to do. Where I do see real value is in research. One of the main challenges of learning computer science has always been that information is scattered across many different sources. In college, this isn't much of a problem because you're surrounded by people who can point you in the right direction when you have questions. But historically, for people trying to learn on their own, finding the right resources has always been difficult. Now, with tools like Deep Search, that information is far more accessible to the average person. Instead of asking an AI to explain a topic, I've found it much more reliable to ask it to find resources, papers, books, articles, or documentation related to that topic. And if you still want it to explain a concept, ask it to explain it based on those sources. In that role, AI works surprisingly well most of the time. Another common question related to AI is whether you should pivot your career toward AI development. There's no accounting for taste. If you genuinely like it, then by all means, follow that path. But if you're considering AI only because it sounds like a future-proof career, I personally think that's risky. AI is clearly a bubble. We all know that. At this point, big companies have hired thousands upon thousands of AI engineers. When that bubble bursts, many of those people will be laid off, and the market will become oversaturated with AI talent. Friendly reminder, no one can predict the future, so I might be wrong. Personally, I think a safer bet is cybersecurity. Even if AI succeeds and companies normalize AI-generated code in critical systems, they'll still need people to verify that the code is safe for production. And if they don't hire those people up front, they'll definitely need them when things go wrong. What projects do I recommend building to improve your programming skills? Well, for starters, my friends over at CodeCrafters have a list of projects you can build using almost any programming language. They're not sponsoring this video, by the way. If you don't want to spend a dime, they also maintain the top 1 GitHub repository in the world, full of articles and tutorials on how to build almost anything. You don't need to pay for that. Just pick something you think sounds interesting and start building. Will I ever cover the inner workings of popular operating systems other than Linux? The problem with this question is the word popular. When you say popular operating systems, you're basically narrowing the list down to 3 options. And since Linux is already excluded, that leaves just 2. The issue is that both macOS and Windows are not open source, so there's very little documentation on how they work internally. Do I think game development is a good way to get into programming? I'm probably not the best person to answer this. I've tried getting into game development 3 different times, and I failed. Not because I didn't enjoy it, but because for every hour of coding, I spent 8 hours drawing assets. Art is definitely not my strength, so I always ended up quitting. Console.log. Do you like cats? By the way, the computer you see in the background is no longer with me. Once Microsoft dropped support for Windows 10, I ended up rage selling it, mostly because Windows 11 is, in my experience, the worst OS I've ever used. So this MacBook is all I've been using to produce my videos for the past 3 months. I've been daily driving macOS ever since. What level of abstraction is acceptable? This question is hard to answer without more context. The only thing I can tell you is that abstraction isn't always bad. I certainly couldn't explain how your web browser uses transistors to play this YouTube video. Have I ever encountered a programming problem I couldn't solve? I've never hit a programming problem that was fundamentally unsolvable for me. I remember some challenges given to me by professors in college took up to a week to figure out, but I've never walked away because I couldn't design a solution. The closest answer I can give to this question is pure functional programming. It's not that it's impossible for me to learn, I just strongly dislike that style and deliberately stay as far away from it as I can. Even in languages like Rust or JavaScript, I tend to write mostly imperative code, because imperative code describes very clearly what a computer is actually doing when it executes a program. Will Python performance improve? How has Python changed regarding parallelism? I'm assuming you're asking this because of the recent discussion around removing the GIL. For those who don't know, deep inside Python's interpreter, there's a special mechanism protected by mutual exclusion called the GIL, short for the Global Interpreter Lock. Its purpose is to ensure that even if you spawn multiple threads, only one of them executes Python bytecode at any given time. Back in the 90s, when processors were single-core and the main purpose of threads was concurrency, this wasn't a big issue. But in modern systems, where almost every CPU has multiple cores, that design decision has become a major limitation because concurrent Python code cannot actually run in parallel. Completely removing the GIL would allow Python threads to truly execute in parallel. So yes, Python is very likely getting faster. By the way, for the past 20 years, the GIL has earned a pretty infamous reputation, but there's a solid historical reason for why it exists. Let me know in the comments if you really want me to post that one last video before 2026. What makes me hate JavaScript but love Python and C? Ever since I showed that meme card in one of my first videos, I somehow earned the permanent title of JavaScript hater. Which is funny, because I don't actually hate JavaScript. While many people call it hatred toward the language, I'd rather describe it as a personal tradition of rage-baiting those who feel the need to shove JavaScript into every possible problem space, and then act offended when anyone questions it. This comment I got almost when I created the channel is a perfect example. You'll hear people demanding respect for runtime developers because JavaScript is now, I quote, a different beast. And look, runtime engineers absolutely deserve credit. But let's stop pretending that this performance is some kind of miracle of language design. A massive chunk of that speed comes from modern hardware doing the heavy lifting. Deep pipelines, speculative execution, absurd cache hierarchies, branch predictors that might as well read your mind. Modern CPUs are insanely forgiving. That's a huge part of the reason a dynamic, late-bound, garbage-collected language can pretend to be competitive in places it was not originally designed for. Now, you might be wondering, how is Python any different? The difference is that most Python developers are quite aware of the limitations of the language. Every time a serious Python developer encounters a performance problem, the reaction is usually, okay, Python runs like shit here. Let's write this part in C. I just want to clarify that JavaScript is my second most used language, and if I were sent to that island and forced to choose between JavaScript and C++, I'd pick JavaScript without even hesitating. Unlike JavaScript, which I think is good for what it's meant to do, C++ in my opinion is straight a very bad language, and it's only where it is because for many decades there hasn't been any more choices. And to be clear, this criticism is not directed at the people who work with C++ or use it professionally. Quite the opposite. I genuinely admire C++ developers. I honestly don't know how they've managed to put up for more than 30 years with all the questionable design decisions made by the people who have driven the language's evolution over time. Okay, final question. If I were to redesign computers from the ground up, what would I change, starting with the instruction set architecture? I have to say, this is one of the best questions I've received in quite a while, mainly because I like to understand things for what they are, not for what they could have been. I wouldn't actually change much about existing digital architectures, but one thing I do think about is how analog computers were essentially forgotten early on. I believe that if we hadn't abandoned that line of development so early, analog computing would be far more mature and possibly far more useful today. If you want more context, I recommend these two videos. I'm going to go ahead and wrap things up for now. If you want to support the channel, please check out the sponsors in the description below. And if you enjoyed this video or learned something new, please hit the like button. It's free and it helps me out a lot. See you in the next one.